I feel like it's what? Like it's supposed to be passed on, like it's not a legacy.
I'm gonna have you guys paint in the dark for maybe just about a minute, and so be prepared. Just have to test a Zoom connection here. Hello, hello. Good morning.
There we go. Good morning.
All right.
All sorts there.
Breaking
Bright
up a
shining
little.
faces.
Oh, there we go. There we go. Yeah. So this is our
Okay.
test. These are our oil painters
Ooh,
that are here right now,
Well,
Bob,
there's-
for our test.
this is, I don't know whether you can see my cursor, but the over this shoulder back on, that's my newest oil painting.
Oh, get out of here. What have you been
looks-
painting?
Oh, no. No, it's the newest one we collect. We don't produce.
Gotcha. You're on
No,
the creative process.
yes, the only thing that I paint is, or finish would be furniture.
Very good. I'm
Or walls.
gonna turn off the lights here and make sure you're projecting well. And then we'll call it good and then meet
Okay.
in about 25 minutes.
Okay, let's see. And I want to try to share my screen.
Okay, there we go. That works. One more test here, guys. So bear with me for a minute. This is Dr. Bob
Okay.
from Princeton, who is
Well, and
done some important marine biology projects we're involved in. Let's test your audio there now.
okay, test 1, 2, 3. Test 1, 2, 3.
See.
Okay. And then the last thing I would like to, we should make sure that my
A bit of an
display is
audio.
working.
Speakers should be go.
Audio okay?
Oh, are you doing it on the
Trying to-
strip right here?
Yeah. I wonder if it, oh, hey, that might be it. Thank you, ma'am. I'll be done here real soon. All right, I think we found our problem. Why don't we try audio again now?
Okay, test 1, 2, 3.
Hey,
Test 1,
that's
2, 3.
excellent.
That look good?
That is fantastic. So Dr. Bob, he was just sharing with me that he has some oil, a recent oil painting on his wall, and that he's on the collecting side of the oil painting creative process. So you guys have a potential customer here. All right.
Yes, that's right. Right over my shoulder back there on the wall.
That's fantastic, Bob. Thanks so much. I think we're all systems go.
Okay, let me try to share my screen, and that will also provide a good advertisement.
You can, yeah, you're advertising for a marine biology class and this project simultaneously.
Okay. You should.
All right. What do we have here? Is that you in front of an icebreaker?
It is indeed. That is me in front of the Nathaniel B. Palmer, which was used to launch two of the two floats that you have already been studying, the Mesosaurus and the Codfather, on a cruise a couple of years ago. And this was that vessel has been. Oh, are we ready to start the official thing?
No, we're gonna go ahead and conclude our test, and we'll reconvene.
Okay.
At, I think 25 after the hour.
Oh, okay. Yeah, I was thinking. Yeah. So this is that is the Palmer. So
Awesome.
it was used to launch two of the floats that y'all looked at. It is the United States' largest icebreaker, and they do have two others that are virtually identical to this. But yeah, it's about 330 feet long. Here,
Wow.
we're 6 miles off Antarctica. I'm standing on the sea ice, so I've got about 12 feet of ice underfoot, and then there's the better part of a mile of water below that. This was
Awesome.
in the local wintertime. Let's see, this would have been sometime in June 1996.
Very good. Hey, well, we'll save the rest of the stories for our actual class coming up soon.
Okay, well, I will start over with them, and you want to just leave this this figure up?
That sounds great.
Okay, and I will
And
see
we'll
you
use
then.
we'll use that same Zoom link.
Okay, and oh, you want to just leave it open?
That'd be fine. I don't mind. Yeah, just leave it
Yeah,
open.
well, we can just leave it open, and if you want, leave this figure up.
Sounds good.
Okay, and I will see you at
See you at 25 after.
yeah, 25 after. Okay.
All right.
We
Thank
will,
you.
We will. Yep. See you then.
All right, see you then. Guys. Okay.
Are you doing it? No, I'm not, but I practice. Oh. No, I'm really not doing it. It looks awkward. It's not a practice. It looks taller. You brought it, right? Yeah. The end post is like this, and it's like.
It used to be called junior designer. They changed it to be like that. They don't want to be associated with the fashion.
Oh, gosh.
I see. Oh, my.
Yeah, I'm just gonna go over the yeah. Because it's too hard to go around it. So did he get a replace? Why? Why something? That's not right. Exactly. Oh, sorry.
What should I make?
It goes into the far right. At the top, yeah.
You'll see, there's a bunch of other ones. That's great. I see. But it's just like, I don't see. There's bread. That's the first one. Like, I was thinking like a plum color, like if you had a plum. Alex, are you doing the sugar plum thing? I haven't decided yet. Like, if it's like that, I don't know if it's the sugar plum. Like, it would be weird that it was I think that what is there? Pound. It was pound. Yeah. I was like, is it really fun? Oh, really? I know. Went to my mom's clinic. Laveda? Yeah, Laveda. Yeah, apparently she just, apparently, really? Yeah. Yeah, apparently she was like, yeah, she used to get her. There's like groups like 79. I also use them. Yeah, so I would have their own style. Better not. That's why she's like, I think I'm gonna make these flowers and
You know, Eli and I were sitting yeah. It was so fun. Except it wasn't funny. It was very serious. You went to jail.
hilarious. Yes.
No. I don't think you should.
Don't worry. I would have slapped her. That would probably. I would have been like, oh, you're doing that.
No. You try, I'm like, I have no idea. It came into my mind.
I turned down like a working I had an interview and he's like, it was that. I was like, so it's my like 4 hours. I was with my mom. I was like, it's like, Joe works there, and Ellie works there. And the weekends work with yeah,
Okay, it's time to start thinking about cleaning up.
that story. She was like, but the nice thing that oh, no, it's gonna be good. Bye.
Oh, yeah.
He's like, no, that's not what happened. Keep talking. Like the supervisor. She was having like the worst day of her life, and then these little like angelic, but she didn't like. And the funny thing is,
Oh, that's what those are.
yeah, I thought these were happier. Like one day.
Nice. Well, that's it.
I have like, it's like one's like a talent, the other one I do.
Oh, yeah. Yeah, yeah.
How dare you say that?
That's why everyone tries, yeah, good night.
That one's pretty good. Oh, okay. Thursday.
Honestly.
I didn't went until well after 2 last night, and I feel so good. I literally just cannot. Are you serious? I never remember.
I can't, like, I don't restless. I have like time. Yeah. If I have like.
That's unreal.
When I take that girl. No, it's great. Well, I'm super relaxed. Yeah, I'm not.
Are you supposed to do that? Oh, wait, we have a.
The old man. Like,
I literally had to
Like Rilla having, well, actually, that could be done, that could be the Midwestern.
Maddie does that.
Because she says.
I also went to bed the reason why I didn't fall asleep till
I know my like thing for my for and so and I haven't done I'm in my math and I'm so much power. Oh, I did the calculus. I'm so much problems. Too much. Okay. That's good to know. I don't know. And I can't do my sources for like I haven't read all of this. This quarter.
Guys. Go ahead and drop that line for us, Monica.
Wow, I haven't done math in so long. What are you doing? Subtraction.
Honestly, ever since I figured out a calculator,
I am significantly better at solving for actually doing this.
That's hilarious.
These ranges may be wrong. Wait, I thought you said that we were doing.
No, I said go ahead and do the ranges for homework. No, I said go ahead and do. I said go ahead and do the ranges for homework along with the rest. Use the ranges to help answer. Yep. The other questions. Here's
I was like, why are you doing that?
here's what I don't want. Don't well, you can rush to do it now, but once it hits 9:25, don't rush. If you want to turn it in later today after lunch or something, I'll let you get away with it. You're calculating the ranges. Yeah, you're just doing subtraction. High and low, minus high and low. That's what a range is. Yeah.
Well, you have to use graph, right, to identify what it actually is. I love this person.
Yeah, you have to get the actual quantity instead of the date, and then subtract high or low from high. Yes, no.
Let's say I turned it into everything but the ranges. How much?
I mean, it can't be more than 10.
See, you guys are all gaming the system.
No, really.
I shouldn't say you're all gaming the
It
system.
can't be more than 10%.
That's one strategy. Probably better to turn it in than not turn it in, right? Yeah.
Yeah, that's what I think.
I haven't done the
I'm not actually going to
calculation.
do it.
I haven't done the calculation as far as is gaming the system advantageous or not. All right, we're going to jump right into it here today, guys. We've got about 5 minutes till Bob Key hops on with us here. We've got everything working correctly. I'm gonna attempt to reverse or flip around my laptop.
Noah, are you
And I'm being tracked.
I'm not.
And managing for withdrawal.
You can go ahead and sit. I'll pray and read announcements, and then we'll get going. All right, Lord, thank you for this day, for your kindness to us. Thank you for Bob Key being able to join us. I pray that we'd be a blessing to him as an attentive audience and asking good questions and just being thankful for the opportunity to interact with a scientist who's been working on a project for decades. And so may we just be greatly encouraged by that and the opportunity to have a conversation with him, to learn from him regarding the SOCCOM project in general. I pray that you would bless him and his wife and his family. And we thank you for the keys and this opportunity to interact with streaming real data that's being collected out there in the world that should contribute to a better understanding of your creation and how to be good stewards and take dominion in a way that glorifies you. In Jesus' name, amen. All right, really quick announcements, and then we'll go right to New Jersey. Announcements, no longer boot season. There you go. You heard it, guys. It's no longer boot season. So starting tomorrow, at least according to this timing here, the gentlemen dress shoes with dress socks, no canvas. Gals closed-toe conservative dress shoes, no canvas, per the student parent handbook. Conservative, I'll leave the definition of conservative up to you. I don't think it means Republican or, you know. Usually conservative for men almost always ends up being like a white or blue shirt with a red tie. It's like without fail, the conservative candidate is going to have a white or blue shirt and a red tie. Boys high school basketball players should turn in uniforms and practice jerseys to Mr. Lopez during lunch today. Logos golf first match of the season today. Heading to Bryden Canyon Golf Course. I would just bring my binoculars and watch golf and bird watch the whole time. I will be your biggest fan, Logos Golf. Should be assistant coach. All right, that's all there is for announcement, guys. Not much else. You do need, hey guys, you do need to get your homework in. So do that. Make sure you turn it in up here. Do not be working on it during the presentation. And I will be getting to you tomorrow. We're going to be spending time. Tomorrow we're going to be spending time choosing project topics. And so your homework, and I will put the assignments in your or the papers in your locker for your final paper or your final project for this class. I'll put them in your locker here during lunch or so. And your homework is to come up with 2 possible topics that you're interested in. The 2 options for the project are to write a persuasive essay regarding some aspect of marine stewardship, developing a strong Christian or biblical stewardship ethic throughout the paper, and to explore a particular conservation issue that's interesting to you. It could be current, it could be historical. And then the other option is researching a marine ecosystem and giving a report similar to first semester, but in this case, an interview with an expert is required for that option. So those are the 2 broad options. I'll get those details printed and to you soon. Yes, Hazel.
What's the word count for the essay?
I don't remember the word count off the top of my head, but I'll make sure that's included.
So like 700 words or like
I don't
or
remember.
like 2,000.
I actually don't remember.
Okay. Just put in a book. Sorry.
Yeah. Go ahead,
So
Rilla.
we came up with an idea for like an experiment we wanted to do on. Would you help us locate an expert?
Absolutely.
I feel like that would be kind of.
That can be the hardest part, locating an expert. Absolutely happy to help with that. I enjoy that. I know a couple experts out there, and I just met a couple more recently, and you're meeting one today. So let's go right to the Zoom. It's time. Let me unmute myself here. I'm already unmuted. Hey, there he is. Good morning.
Good morning.
I'm going to turn the camera around so you can see these smiling faces, hopefully.
Oh, excellent.
See if this little clippy
That's always that's half the fun of these presentations is being able to put a face with some of the voices.
Looks like my camera is, let me try something here really quickly. There we go. Switching cameras. There they are.
Oh,
Smiling faces.
good morning, everyone.
There they are.
Hey, all right.
This is our marine biology class. This is the first time marine biology has been offered here at this school, and so these are our pioneers.
Excellent.
And so these are all seniors. Yeah, it's been a great discussion kind of oriented class.
Well, my first oceanography class was actually in 6th grade. We had a teacher who was just interested in oceanography, so she took a 6-week period, and we studied as our science for 6 weeks. But at that age level, you might imagine our project amounted to cutting up cutting pretty pictures out of National Geographic. Which, a lot of parents didn't like that too much, but what else? What's a man to do? You know? But anyway, it was good enough that it got me interested in oceanography, and then I finally wound up going into the field because I had traveled a fair amount during both high school and college. And when I graduated, I knew I wanted to do science, but I knew I also wanted to travel if I could. And that sort of left two options open to me. One was oceanography, the other was geology. And to be perfectly honest, at the time, there were no TV shows to get us really fired up about geology. But Jacques Cousteau was very big on TV. And while he's really not an oceanographer, he's much closer to a marine biologist or really, he was a movie maker. I got to meet him a number of times. But at any rate, that looked much more exciting. So I decided to go into oceanography knowing almost nothing about it. So I did my undergraduate work at a small private university down in Texas called Southwestern University, and then I went to Texas A&M for my graduate work, and y'all can all watch them in the NIT this year. They moved into the quarterfinals last year. You know, go Aggies. So I did my graduate work there, and then if I change slides here, you can tell that I went from there to Princeton University, and I've been there ever since. So I'm part of the Atmospheric and Oceanic Science program at Princeton. I've been there since 1980, and I retired in April of 2020. So when I retired, I was a senior research oceanographer and had put in 40 years there at Princeton. Or if you really want to make me look old, I started going to sea in 1973 down at Texas A&M. So a number of years at sea. What we have in that, let's see, where are we? If I can go back, there we go. This first picture,
Hey,
that is
Bob,
a picture.
real quick, sorry to interrupt you. We have some type of alarm going off. Let me make sure. we Make it
Oh, yeah.
stop. Not sure
Okay.
if it's on your end or my end.
Was that it?
Hey, great. That was it.
That was it. That was my phone telling me that I've got a presentation this morning. This set of headphones is good enough. I couldn't even hear it. But at any rate, okay, so this is a picture of me actually back in slightly younger days. This was taken in the middle of July, 1996. I am, we, the ship and I, are about 6 miles off the coast of Antarctica. We're in the Indian Ocean. Under my feet is about 12 feet of ice, and below that ice, there's about a mile of water. So, the temperature there is, that was a pretty nice day. It was about -10 Fahrenheit. And the ship behind me is called the Nathaniel B. Palmer. It's the largest, one of the largest icebreakers that the United States owns. It is used strictly for research. So it does both cruises, as was the case with this one that I was on here. And it also resupplies the research stations that are down in Antarctica. We have two other ships that are essentially carbon sister ships to this one, so they're virtually identical. But the Nathaniel B. Palmer is the one that we have used to launch more floats, more SOCCOM floats than any other vessel. At this particular time, we were stopped right here. We were doing we came out of Cape Town, South Africa, got down close to Antarctica around 67, 68 degrees south, and then started heading east. And we were doing a section, we were coming all the way across the southern part of the Indian Ocean. And then we went back up into Hobart, Tasmania to finish the cruise. But while we were down close to Antarctica, we got a satellite call from the National Science Foundation. And basically the message was, we've got a bunch of Russians down at the Mirny station on Antarctica, and they're about to starve to death. Can you help them out? this was in the days when the U.S. was getting along a lot better with Russia. There really were such times. It doesn't feel like it right now, but there were. And being scientists, we negotiated to make sure we didn't lose any of our science days at sea. But that of course was just you try to play that card, and if you win, it's good, and if you don't, then you go do the rescue job anyway. But they said yes, they would replace our science days, and so we got as close to their research station as we could, and that's where this picture was taken. Like I said, I'm about 6 miles offshore, and the Russians came out in a couple of vehicles, tracked vehicles, that looked like they were World War II vintage, so something from the 40s or 50s. And we gave them about 4 tons of food and fed them and gave them what medicines we had, and they went back to the research station. And the reason they were having a problem was this 1996 was shortly after the breakup of the Soviet Union. And when that happened, all of the Soviet research money dried up almost overnight. And while the Soviet Union owned some of the largest icebreakers in the world, much bigger than the Palmer that's sitting there behind me, they were all in dry dock. Every one of them was getting repaired, and they didn't have the money to do the repairs. So they had not run the resupply to their station down at Mirny is the name of it. And they were supposed to be there in January. And here it is, we come along in June, July time frame. I think I said earlier it was July. I misspoke. It was June. At any rate, we came by and were able to give them some food. So it made for a really, really interesting day. You don't get to do something like that every day. So it was fun. Anyway, all right. So we're going to be talking about, the other thing I should mention about this vessel, because this will be the last time we'll see it today. But I know that you looked at profiles of probably temperature or salinity from the 2 floats that Will was involved with, Mr. Boyd was involved with, the Mesosaurus and the Codfather. Both of those floats were launched from this ship like I said, a couple of years ago. Okay, so today we're going to be talking about the SOCCOM float program. This is what SOCCOM stands for. Oceanographers, like all other scientists, love acronyms, so this was our acronym. The main purpose of this research has to do with better understanding the movement of carbon dioxide from the atmosphere to the ocean and then back out to the atmosphere. And it turns out the Southern Ocean is an important, just an absolutely critical part of the global ocean for that exchange of gases. And as soon as I mentioned CO2, then I expect everyone sitting there in the class knows that we're going to be talking about climate change. And of course, that is exactly the reason that we're studying this. It's to try to better understand how fast the CO2 is going into the ocean and to hopefully be able to predict when it's going to start to come back out, because some of it will. Actually, some of it already is. But the better we understand that, the better we can predict what the atmospheric CO2 concentrations will be. And the better we can predict that, then the better idea we'll have about what the weather and climate are going to look like over the next 50 to, climate change is a 2,000, 3,000 year problem. It's not a 50 or 100 year. Okay, Southern Ocean circulation has an awful lot to do with the reason that it is important. It's the only place on the globe where we've got a current that goes all the way around. We've got a current that goes all the way around the globe. And because of that, the fact that the Earth is spinning and the way the winds work in the Southern Hemisphere, all 3 of those things combine to make the Southern Ocean extraordinarily important for CO2 gas exchange. This is going to be, if I can get it to work, a little short video that shows you what the circulation looks like in the Southern Ocean, and why it how that circulation helps the ocean to absorb carbon. There it goes. Hopefully it'll do something. There we go. Everyone knows that. Okay, here's Antarctica. The Earth's spinning between the winds, and that Earth spinning that sets up a clockwise circulation around Antarctica. It is by far the strongest current anywhere on the globe. Those two things combined allow water to then shed off this the circumpolar current and move northward. Now they move northward two ways. When they do, that allows water to upwell, and that's what we were seeing here with the arrows coming up on the right side. But we have, because the water's moved to the north, that allows more water to come up from the bottom. If it comes up really close to Antarctica and the ice, then it gets super cold. When it gets super cold, it's really heavy. It can go all the way to the bottom and flow northward. The other pathway, if it upwells, so it's not as dense, and consequently it flows northward at shallower depths. But both of those pathways are extraordinarily important. When that water comes up, then it has a chance to absorb some of the man-made CO2 that's in the atmosphere and carry it away from the Southern Ocean. And that process, the movement of CO2 from the Southern Ocean into the deep waters, is in large part what controls the rate at which the ocean can uptake CO2. If the ocean were not uptaking CO2, the CO2 in the atmosphere would be about twice the concentration that it is today. And it's already so much higher than it was. Gosh, it's a heck of a lot higher than it was when certainly when I was a child, and it's much higher than it was at the beginning of the Industrial Revolution back, say, around 1850. Okay, if we look at that same sort of process on a schematic, now the only thing to keep in, just to keep everyone on your toes here, now south is on the left. On the previous little video, south was on the right. Here it's on the left. So here's Antarctica. We have water upwelling. If it's very close to the continent, it gets super cold, sinks, and flows northward as bottom water. It's a little further off. It doesn't get quite as cold, and it flows northward as what we call intermediate or mode waters. But these waters have a chance to exchange both heat and carbon dioxide with the atmosphere. And because of the atmospheric concentrations right now being both hotter and higher in CO2, the net effect is an uptake of carbon dioxide and an uptake of heat. So the ocean's helping the atmosphere out by storing both of those quantities. Otherwise, we would be seeing a lot more of the effects of climate change already. In your lifetimes, you will certainly see huge changes. Okay, how about most of the talk today, I had a bit of a decision to make. You've already looked at some of the data from Mesosaurus and the codfather. So today I'm going to focus on the one that you adopted this year, which you named SOCCOM's razor, and I absolutely love that name. It's a great pun, and everyone in our group appreciated the name. Your float was launched from this vessel. The name of it is the Sarmiento de Gamboa. It was launched just very recently, March 23rd. Well, good Lord, what is today? That can't be right. I think this is supposed to be March 13th because your float's been in the water for about, it may even be earlier than that. It may have been March 3rd. So this date is wrong. But anyway, your float was launched in March of 2022 from this vessel. Sarmiento de Gamboa, this vessel is about 230 feet long, as opposed to the Palmer, the earlier one we saw. Palmer's about 330 and much, much bigger and heavier and stronger ship than this one. But an awful lot of research vessels look something like this, and an awful lot of them range from around 200 to about 300 feet is the standard size. They typically have anywhere from about, I think the smallest ones would have 10 crew members, and the largest would have perhaps 50. The number of scientists on board on the smallest vessels might range from 7 to 10. And again, on the largest ones, we might have almost 50 research folks. There, I think you've already seen this. This was a picture of your float and some of the artwork that I don't know who did this. I think it's one of the postdocs from out at Scripps that did the artwork on this one. But on the right, you see your float being actually deployed. These are the biological sensors down here. There's also a bladder down there that allows the float to go up and down. All the rest of the sensors are up here on top. This ring has no purpose other than what it's being used for right here. Now you see he's got both ends of this line he's holding, he or she, can't tell. Anyway, the person doing the launch has got both ends of the line, and it goes through a small hole in this ring. Once the float is in the water, then they drop one end of this rope and pull on the other end. Hopefully the rope slips all the way through and comes out and everything's fine. It's my understanding that on your float, the line got tangled and they could not get it out. So I think your float is carrying around a piece of rope with it, and odds are it'll be there the rest of its life. But typically the rope doesn't harm anything as long as it doesn't get tied up in all these instruments up here. This black one that you can't see the top of is the antenna, and the rest of them are the various sensors that are on it. This shows sort of how it works with a different float. This particular one here was called Midnight Sun, but here you see it being lowered into the water. As soon as it's released, the float will float horizontally for a while. At that time, you can see the instruments are already in the water and they're all turned on. As soon as it figures out what the density of the water is, then it adjusts the bladder. It's nothing more than an inner tube down here at the bottom, a small inner tube, but it'll adjust the inflation level of that inner tube, and that changes the buoyancy of the float so that it flips upright, and then it spends the rest of its life in this upright position. So once it gets upright, now you can see the antenna. I think it's very hard to see. There it is, that disc. That's the antenna, and it's somewhere there. That's probably it right there. But at any rate, the antenna will talk to the satellite. The signal will come back to shore. It says, I'm right here, gives its latitude and longitude, and then it begins its mission. All right, this, I will not talk over this. This is a little video that shows you how the floats work. And there's too much going on in this video for me to try to talk over it. So your chore will be to try to keep up with the text on the screen, and then I can go back over any of it. This is also a good place to have a first set of questions. So this only lasts about a minute. There's the bladder. Okay, that's a good place. Are there any questions about how it works? Somebody's got to have a question.
I have one, Bob, if no one else does. Can you hear me?
Sure. I'm having, I can't quite hear you.
Can you hear me now?
Oh, absolutely.
Okay, great. Doesn't look like any of the students have a question. I have a question that's not quite related, but a little bit tangent here. How much movement do you see as far as just miles? Do most of these floats tend to stay within some type of range during their lifespan of their deployment point, or do you see some that get caught in different currents and move significant distances?
You see both. Occasionally we will have one that gets caught up in an eddy, which is sort of like a whirlpool of water, and they, as long as they're in that eddy, they will move at the same speed the eddy does, which is typically quite slow. Others that are in the Southern Ocean, they get caught up in that Antarctic circumpolar current, and we've never had a single float that moved all the way around the world. But I was looking at some data from one yesterday that we launched. Do I have a map in this presentation? Whoops. Yeah, I don't want to start that. Anyway, it started it was off Antarctica in the western South Pacific, and it's still going, but it had moved through the Drake Passage. So it was it had moved from all the way across the Pacific Ocean and is now in the Southwest Atlantic Ocean. So that's thousands of miles. I would guess that almost all of them move hundreds of miles during their lifetime. Assuming the batteries last for the full 5 years. That suite of measurement. Now, most of the time when they're drifting, they spend most of their life at 1,000 meters. So they are primarily going to track the movement of water that is at 1,000 meters, or if you want 3,000 feet, or ballpark 3/5, say 60% of a mile down. So they're not moving as fast as the surface currents are, but they can get up and move along pretty quickly. That suite of measurements: temperature, salinity, pressure, oxygen, nitrate, pH, and then there's some biological things that reflectivity or chlorophyll. That is the suite of measurements that we sort of the minimum suite of measurements that we need to understand the carbon system in seawater. Now, there's only one parameter there that's directly related to the carbon system, and that's pH, or the acidity, if you will. You've probably, if you had a chemistry course, actually, or in biology either, you may well have talked about pH. It's nothing more than the acidity of the whatever it is you're talking about. In the case of the ocean is slightly basic. It has a pH that's around
But that eventually might happen here. Let's see. Might have to try to reboot.
it won't go blunt. It will still be basic. Okay. This is another video. This one sort of takes the last picture, which we saw of the float, and it translates it into shows how the SOCCOM data works with the rest of the data that we collect. So here's a picture of the Palmer. There's the picture of a float, and you can see that the float data is only one part.
Research ships have long served as the backbone of oceanography. They're costly, and it's very difficult to collect data year-round. The Southern Ocean Carbon and Climate Observations and Modeling Project, or SOCCOM, was established.
Now, are you hearing the audio portion of this?
It's a little faint.
Okay, let's see. I don't know if I can turn it up or not. I'll try.
With an eye to a future where an army of robotic floats could be deployed to monitor
That's
ocean
great.
health at all times of the year
There we
and
go.
in all kinds of conditions, something not possible by scientists on boats, and at a fraction of the cost and carbon footprint.
Okay, I'm going to stop it right there and just review a little bit. That's Heidi Cullen, who I would guess that a fair number of you have seen on TV. She was one of the primary people at Climate Central, which made an awful lot of NOVA and documentaries over the years. She has since left Climate Central and is now working at the Monterey Bay Aquarium and Research Institute. But at any rate, whoops, sorry about that. Oh, shoot.
Research ships have long served as the backbone of oceanography, but they are costly and it's very difficult to collect data year round. The Southern Ocean.
Okay, this is good a place to stop as any. Now you can see the ship's going along. It has dropped a float here. Then that float is drifting. It's just dropped another one. That float's going to drift. And the important thing to notice is that the measurements we make aboard the ship cover the full water column. So they go from the surface all the way down to the bottom. And say pretty much regardless of how deep it is, we can sample down to within, if you're really a gambler, you might get 15 feet off the bottom, 10 or 15 feet off the bottom. The floats, on the other hand, only cover the top 2,000 meters. And that's because the cases that they're in, the containers that have all of the electronics on the inside of them, simply will not withstand the pressure any deeper than 2,000 meters. The other thing you can see is the ship certainly does, and the floats are communicating via satellite. The signal, every time they come up, they talk to the satellite, bounces off the satellite, and goes back to land. And then it'll finish up with this video will finish up with the satellite data. So I'll hush now and let it run.
Carbon and Climate Observations and Modeling Project, or SOCCOM, was established with an eye to a future where an army of robotic floats could be deployed to monitor ocean health at all times of the year and in all kinds of conditions, something not possible by scientists on boats, and at a fraction of the cost and carbon footprint. Floats equipped with biogeochemical sensors make it possible.
One thing I want to point out to watch this float. It's now under ice, and watch what it does.
To measure not only salinity and temperature, but also factors linked to bio, like pH, oxygen, nutrients, and chlorophyll. Floats collect these ocean chemistry and biology observations between the surface and 2,000 meters deep. The data are transmitted back to shore via satellite and made freely available in near real time, so they can be used by researchers, educators, and policymakers around the world. Ultimately, the powerful combination of research ships, a global array of biogeochemical floats, and satellite observations of the ocean's surface are transforming our ability to observe and understand our ocean, and will allow us to better predict how climate change will impact the ocean in the future.
Okay. All right, so what Heidi said is exactly right. When I first started doing oceanography, the shipboard sampling with what we call a CTD rosette system was brand new, and that was the only technology we had to sample the ocean. In the time since then, we've added the satellites and most recently these floats. So we're getting a much, 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 much better picture of the ocean, and we're doing it in a much more cost-effective manner. I'll take just 2 minutes and talk about costs. These floats, your float, SOCCOM's Razor, it's about 5 feet tall. It'll last 5 years, and the cost of that float is about $110,000. which is a fair amount of money, obviously. It seems like that is expensive, but then when you divide that by the other information we've gotten in these last two videos, so we know that when things work, that float's going to last for 5 years, and it's going to make a profile every 10 days. If you start doing the math on that and figure out how much it costs to do each profile, you'll get a number that's is relatively just non-existent. It's almost like they're free. That has to be compared to the cost of getting a profile aboard a ship. Now that ship costs, just for the ship alone, costs $55,000 to $75,000 a day, depending on the ship, and that's with no work. If the scientists on board, you take 50 scientists, add up their salaries. The Rosette system we use is $250,000. Sometimes we lose those, but we can do no more than 3 profiles a day for all of that money. And if you do the same sort of math on that equation, you'll find out that shipboard analyses are very, very expensive. Most of it's because of the ship costs. But the good part, the reason we continue to do shipboard measurements is they are what we call the gold standard. And you've all heard that phrase with COVID over the past year or so. And by that, we just mean that the very, very best measurements are the ones that people make aboard ships. And so we continue to do the shipboard measurements, and we calibrate the float data to the shipboard data. Same thing with the satellites. All a satellite can really measure is what can they can measure infrared radiation, they can measure color and things like that. So that data very definitely needs to be ground truthed. And again, they go back to the shipboard data to do that. So we still need the ships. All right, so now let's go on. Look at SOCCOM's razor. Here it is, South America. This is the southern tip of Africa. So Cape Town is right about there. And this is where your float was launched. This is one of the pages that you can get to on the SOCCOM website. And it's not shown on this figure, but up here, it would be in the upper left. There's a little panel, and you can simply put in the name. You can't put in the name, but you have to put in the number for your float, and it will start blinking, or it will highlight like this one is. And then if you zoom in on that, you could see, you get this picture, which in this case doesn't show very much, but here's where the float was at the time that we made this figure. And in earlier times, these 2 very faint gray dots are the 2 preceding profiles that it had made. So it had made 2 profiles sometime very soon. It would make its 3rd one. And you can tell so this picture wasn't rotated or anything. So it is moving to the southeast, or if you want, it's moving this direction. All right, let's go to the next one here. This is the first profile from Occam's razor. You can make the equivalent of this from the SOCCOM Viz website, and I know you've been doing this. These are just a little fancier in that it shows we make this for every float that gets launched, just to make sure everything is working. And I know you've gone over this in your class. So I'm not going to spend a lot of time on this, but the things, since you're a biology class, the important things to notice are the chlorophyll. I'm sure you all know what chlorophyll is. It's got this huge spike up here in surface water. That's all the phytoplankton up there going to work, producing oxygen and so forth. pH we talked about is the whatever color that is, purple, and you can tell these numbers are simply wrong. So earlier I said that the ocean was basic, and what's happened here is this one has a calibration issue. We frequently see that with pH on the first profile. So we know that this one, like I say, it should be almost 1 entire pH unit higher. And I'm sure the second and third profiles by now, if you went to SOCCOM Viz and made this up, the pH would these numbers would jump up into the 7s somewhere. The profile would probably still look quite similar, but it's purely a calibration issue. Temperatures, not surprisingly, warmest at the surface, and the water here is quite warm. Actually, wow, it's really warm. 22 degrees. Of course, that's centigrade, 22 centigrade, but room temperature would be about 25 centigrade. So it's the surface water there's quite warm. Very quickly, this is called the thermocline. Thermo meaning temperature, cline meaning gradient or place of change. So this whole thing through here is the thermocline, and it very quickly gets down to typical deep water for that part of the South Atlantic Ocean, which is that's probably 1 degree, somewhere in the range of 1 degree. This water is moving northward from Antarctica. That intermediate water that we talked about when we were looking at the way the Southern Ocean circulation works, that would be this water right here. And you can tell it's high in oxygen. So it was recently up at the surface. It picked up oxygen from the atmosphere, and it shows up as a relative max in the local profile. Anyway, all sorts of things you can do with these now. And again, on the SOCCOM Viz site, you could, for instance, plot temperature versus salinity. And this particular plot doesn't even have salinity on it. But if you put salinity on this axis and temperature on this axis, then the location in that plot will be indicative of density. Down here in the, let's see, this is salinity. So high salinity cold water would be in this corner if you made that plot. And so the highest densities are here. The lowest densities are going to be up at this corner. And the plot will, we call that a standard TS plot. The figures would go across it in some way. Anyway, it's a good plot to make and tells you something about the density. This is the cruise track that the Sarmiento de Gamboa made. The light shading, of course, is the topography. We've got the Mid-Atlantic Ridge here that everyone knows about. This is another set of high tectonic activity and a ridge. Your float is this one. The reason that's the SOCCOM's razor. The reason I put this up, I would like to encourage you to have some fun and go off, and in addition to looking at your float, look at this one. And the name of this one over here is, let me look it up so I don't forget, Mesa Yellowfin. It's in the same place you get your data, is Mesa Yellowfin. You can look it up. And the reason that it is of interest is it was launched on purpose in a very weird area. Now, to tell you what makes it weird, I'll have to tell you a little bit about the circulation. And here we're talking about surface circulation, but we have waters that come from the Indian Ocean southward. They're east of Madagascar primarily. They come down, it makes a current across here close to shore moving to the west, and it's called the Agulhas Current. When it gets to about this area, it turns around quite tightly and then heads back to the east. And that area where it turns around, we've got to put a 25-cent word on it. So that's called the Agulhas retroflexion. But it's very much like a current that also does that in the eastern Gulf of Mexico. In the Gulf of Mexico, the water comes through Yucatan, goes up off Florida, turns to the east and loops back down. And in both of these currents, when they retroflect, occasionally they pinch off eddies, or those little cyclones, if you will, of water that's moving in a circle. Now, given the way that I drew that, you can imagine if that pinched off, then the water is going to be flowing in this direction. when it closes back up. So it'll be counterclockwise. Also shown on this figure is the last time that I was out to sea. I was on this, these lum numbers are totally unimportant, but it's the way we keep track of the repeat lines that we do globally. A is just Atlantic. And when we first made up this scheme, there was some logic to the numbering that's pretty much fallen apart over the last 30 years. But anyway, we keep the same lines. And I did A13.5 back in 2010. And the next figure I'm going to show you is next two figures are data that we collected on my cruise. And they could have been collected on this one as well. It just depends. I wasn't aboard, so I can't tell you exactly what they did yet. Hopefully we'll get copies of the data before too long and we can find out. But this is a picture now. It gets a little bit graphic here because this is satellite data. Here's Africa. And let's see. Okay, so this intersection, note we're a little bit east of zero, and we're more or less, these were planned stations. The line actually was about here. They went a little further north. But anyway, they're around 30, 32, 35 south. Now, this is a satellite picture, and what we see here is the height of the ocean. Now, if you're out there on it and it's a calm day, the ocean looks like it's just as flat as a skateboard. I mean, as a concrete slab, but it's really not. There are places where it stands a little bit taller. There are places where it stands a little bit lower, and all of those depend on they're primarily due to the temperature of the water. Just like if you take a bottle of hot water and put it in the refrigerator in a glass container, say if you get a Coke bottle, fill it up with hot water, take a magic marker, put a thin mark at the top of the water, and then put it in, and don't freeze it, but let it get right down to 32 degrees. What you will find is that the water has compressed just a little bit, and that's because it's gotten colder, and colder water has higher density. You haven't made any new water, so if it's more dense, it takes up less volume. But that's what we're looking at here. Is these are areas where the water stands a little bit taller, so it's less dense. These are areas where the water is depressed a little bit. The surface of the ocean is depressed a little bit, so they sink down a little. And these are all these ones that are red are shed from that Agulhas current. Now, there was one that was shed right here, and that's a date and a time, but it was, and then these are 1 week intervals. So there was one that was shed here, and there are people that make their living tracking these things. But
just so you know, Bob, we're about 5 minutes out.
Ooh, okay. At any rate, it drifted across, and then we wound up sailing about a week after this figure was made. This particular eddy was right there, and we sailed through it, and that's what the profiles looked like. Now here we're looking at depth on this axis, and we're south to north. So this is south, this is the north, and this is what that eddy looked like in profile. So these are all lines. If you take this line, everywhere along that line, the salinity is the same. So we're plotting salinity. The colors in these lines convey exactly the same information. So this is a, let's see, counterclockwise spinning eddy, and that makes it, the water things look like this. And at any rate, if you go off and additionally get data from Mesa Yellowfin, you could very well see the same sort of thing. Now, the rest of these, let's have a few questions, and the rest of these, they're just pretty pictures and fun things from being out on the boat. But I'll just slowly go through those while we're talking. And anything's fair game. If there's plenty of jobs in oceanography for all sorts of people, from technical sorts, hands-on sorts, mathematical types, theoretical types, and we certainly, and it's roughly the field now is actually it's about 55% women now. So
Oh, we got a couple questions here for you, Bob.
okay, go.
Hi, so what has been the biggest accident you've had with a float, and you had to do you have to recover them if something happens to them, or have you had any accidents, or how does that work?
Everyone we've put in the water, we lost. It turns out that it would cost more to sail out to get them than they're worth. So at the end of their life, when the batteries run out, which is about 5 years, they simply sink to the bottom, and they eventually dissolve. The casings, the shells on the outside are made out of aluminum, and the alumina dissolves, and then everything except for a very small amount of plastic will eventually dissolve. In terms of accidents, we've had a couple that ran into the bottom. There was a seamount in the Pacific. One of them went down and got stuck on a seamount, and it was stuck there for about a year before it got dislodged. It's always possible that we've had a shark bite them, but since we don't recover them, all we know is that occasionally they die. Far more likely scenario is that they spring a leak in the cap. Some part fails in the lid, and they get water in them. And of course, seawater and electricity don't go together very well. But
That's good. We got another question here for you.
What does an average day on board a ship, like gathering data or researching, what does an average day look like for you on board a ship?
oh goodness, that's a great question. Average day, they go 24 hours. When we are on a boat like this, the costs are so high that we have two crews, one, and I'm just talking about the scientists. The guys that run the ship work on a different schedule, but the scientists typically work 12-hour days. So you would work from noon till midnight or midnight till noon. And during that time, you would typically take 3 sets of samples. And that's about what they're about to do here in this picture. Let me see, is this a movie or a picture? It's a movie, yeah. If I let this go for a while, there you can see the equipment, and it's coming out the, is that a, there it is. There's our CTD rosette system. And this young woman is giving instructions to the winch operator, that finger down, and she's rotating her hand. That's saying lower it down. So we run this thing up and down. As soon as it gets up, everyone samples it. Occasionally you get very wet. That was on a nice calm day. Yeah, it can get exciting. It can be a little bit actually it can be a lot dangerous. So you're careful, and you can see she's got on her steel-toed boots and her water. These are called Mustang suits, hard hat, good set of gloves, and so forth.
Hey, that's great, Bob. We have a bell just rung. Maybe a couple students can stick around, but if not, let's give, excuse me, Dr. Bob Key a big thank you, guys. Thank you, sir.
Thank you. I'm glad you enjoyed it. And I know Mr. Boyd has got a thumb drive that has all sorts of additional slides on it and pictures of going out at sea and things, penguin pictures we've taken.
Yeah, that was, I have a confession to make, Bob, and a humble request. We had a recent move and I'm having trouble locating that thumb drive. Is there any chance you'd be able and willing to give
Absolutely.
me a
Yeah.
new copy?
Yeah, no problem. Let me make sure. Well, I'm pretty sure I've got a mailing address for you. I can't get this thing to leave this page right now, but there we go.
Yeah, that'd be great. This is such a blessing for our students to have this kind of culminating interaction with with a scientist who's been involved for a really long time. I'm sure you know this, but I can't express how valuable this experience is for our marine biology students. So I'm really just thankful for your continued efforts in making this possible.
Oh, I enjoy doing it because, well, Moscow is 10 times the size of my hometown.
Okay.
And we had one doctor in town. That was my dad.
Ah,
We had 0 scientists. We did have some, bachelor level geologists because we're in the middle of the oil patch. But yeah, I know it's hard to get. Yeah, real world scientists are we're not a vanishing breed, but it's a small community.
right.
It really, and it doesn't matter what science you're talking about. There just aren't a lot of us out there. Let me see. I've got PO Box 8605,
That
Moscow
works. That's great.
83843.
You got it.
Okay, yeah, I can send you another thumb drive. I buy them, 25 or 30 at a time. So
Thank you.
yep, and I will load it up with additional links and pictures. I will put the full deck. We only got, let's see, there we go. There's a whole lot more figures
that's
on
great.
here.
That's great.
There's a whale pictures. If it was a younger class, the first question is always, have you ever seen a whale? Yes. There's one up close and personal.
Did you see that viral photo or little video from a ways back of 1,000 whales off the coast of Antarctica in the Southern Ocean, all kind of surfacing simultaneously?
I don't know. I didn't see that one, but I have seen similar sorts of displays. And that cruise, the first slide that I had up while we were doing a station during that cruise, the first thing the ship does when we're working in ice is it would stop at the location we wanted and then bang back and forth. Essentially, we would make a hole in the ice. Big enough so that we could get the equipment over the side without risk to the equipment. And while we were sitting there running the CTD Rosette up and down, this huge, I don't know I think it was a blue whale and her calf came up, and they spent about 2 hours surfaced and just talking to us.
Wow.
She would roll over and stick this gargantuan flipper up and down, and the little one, of course, was just swimming all over the place. But that was just a marvelous day.
Oh, yeah.
And as you can tell from these other pictures, the other thing you see down there, because most of the time you're not that near land, but there are birds everywhere. And then when you get close, the penguins are always cute. This is what my students look more like. This one was one of my students, my last student. And they're this picture was taken at the German research station. It's called von Neumann, about 0 on the prime meridian in Antarctica.
Wow. That's fabulous. Okay. Oh, wow. Look at that. Goodness.
Yeah. You go sailing in amongst the icebergs. And then,
Bob, just to kind of connect the dots between you and I, that was my birth year.
Which one?
77.
77. Well, that's me.
That's a big year for marine biology. 77 was Alvin and the deep sea submersibles. Yep. And discovery of hydrothermal vent communities.
Yep.
That's a big year.
Yes, indeed it was. And here we're working. I think this is in the Gulf of Mexico. This is like a 30-liter Niskin bottle. We needed that much water because we were running radium-226 and radon-222 very near the surface and very near the surface ocean to look at exchange of gases between the sediments and the water and between the water and the atmosphere. But yeah, this is Tone Lee, who puts all these talks together for me. This is her.
Oh, that's fantastic.
Yeah. We met in graduate school. Good friend here. That's what the Niskins look like going down. You cock the top and the bottom open. the bottom's not open on this one yet, but that would happen pretty soon. And that's what a rosette used to look like.
Okay.
They look essentially the same today. Oh, and this was when I first started doing C14. We were collecting it in these things. Those hold about, they hold right around 250 liters of seawater. It's called a Girard barrel. And this cap is actually a scoop, so that while you're lowering these, we'd put 9 of these beasts, wherever my cursor is, there it is. We would put 9 of these on the wire at one time. It's a different cable we would run through this shiv here, as opposed to the little shiv here. We'd be using this big one. But hang 9 of those, lower them down. This scoop would force water. It would go up, hit the scoop, go across. There was a dividing plate in the middle of these barrels. They would go all the way to the bottom, underneath the dividing plate, and back up and out the lid on this side. So that's how they flushed. Then when you got to position where you wanted to close these things, you would drop a weight, hang a weight on the wire and drop it down, and it would hit. Oh, there was a mechanism up here that would close the lid and drop another weight, so it would close the next one down. But
I love the engineering that comes into so much of this work, and the engineer types, they're so critical.
Oh, absolutely.
Unfortunately, I have to get going, but I want to put a bug in your ear before I split. I'm very interested in marine biology and also professional development as a teacher. I also hope eventually to pursue a PhD program in intertidal ecology. Would it be okay, and I'll communicate with via email also on this, but would it be okay to use you as a professional reference for any of those kind of opportunities that MBARI or other professional development opportunities that are out there?
Oh, of course. And are you talking about like George Matsumoto's thing at MBARI, or?
Yeah, there's something there, and there's also this program that the Murdoch Charitable Trust does for teacher professional development, where you can team up with a scientist to do 2 years of research and then a poster presentation and that kind of thing.
Yeah. Oh, absolutely. And yeah, I can probably get you in. I can never guarantee anything like that, but I'd say that if we write you a letter, a recommendation letter for MBARI for any of their programs, we can pretty much, the odds would be good of getting you in.
Awesome. Thank
because
you.
Well, the follow-up to SOCCOM is a program called Go GBC, and it is to put these same floats in the rest of the world. And for that program, the director is a guy named Ken Johnson, and he's at MBARI.
Okay.
And Heidi Cullen, who I work closely with, is at MBARI. And George Matsumoto, the guy who you worked with to do the official adoption, he's at MBARI.
A lot of great people down there.
Yeah. So you've definitely got the fact that you've adopted a float I would say would be a huge step toward getting into any of their. Here's, speaking of biology, there's a big one of the nets.
Wow.
That they use for phytoplankton sieving, gravity cores.
I wish I
did fun and games.
Oh man, I wish I didn't have to go.
I could give a 3 hours.
Got a Zoom class coming up, Bob, and thanks again. This is real pleasure.
Okay. All right. And yeah, you'll enjoy the thumb drive. It will have a ton of stuff on it. So,
fantastic. Well, thanks again, sir. And
you bet. My pleasure.
Look forward to chatting again sometime.
Okay, good enough.
All right. See ya.
Yep. Bye-bye.